Great to see you here again. In this new video, I'm going to do some exercises related to the normal probability distribution. And it's very interesting to see how we can apply, how we can do the calculations, and how we can adjust them or use this to provide people with relative information, probability information about events that can happen. But before we continue, do not forget to click the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's start with this now. The first exercise is quite simple. We look at the normal distribution with an average mu equal to 125 and a standard deviation of sigma which is equal to 45. Now we want to know the probability that x is smaller or equal than 155, and we want to use the norm point dist and the norm point s dist functions. So now you can use it, you can stop the video, you can use these functions in Excel and see that you find the same values like me. So you finished it? Okay, let's have a look at the solution or our solution. And the first element is norm point dist. We have the value of x, 155, the mean, 125, 45, which is the standard deviation, and we have the parameter true, because we want to know all the probability for all values smaller than 155. So we have to select the cumulative distribution. And we find 0.7475 and so on, or 74.75075%. It means that there is a probability of approximately 74.75% that x will be smaller or equal than 155. Now we have to do the same thing, but now we are using the z value. Now you can stop this video again and calculate the z value and put it in the formula, in the function of Excel, norm point s point dist. So when you finish, continue with the video and compare the results. So you finished? Okay, let's have a look. First, we calculate the z value. So we have x minus mu divided by sigma. So we have 155 minus 125 divided by 45, which is equal to 30 divided by 45, or 2/3. When we use this, it's better to use the fractional expression, so 2/3, or just calculate z in one field and use that field as an input for the norm s distribution function. Because 2.2 divided by 3 is 0.6666, but you cannot fill all the numbers in there, and 2/3 is 100% correct. So norm s dist, 2/3 and true gives us the same value, of course, like the previous calculation. This is logical because we were using the same numbers. Let's have a look at exercise 2 now. And the second exercise is a little bit more complicated. We have a normal distribution with an average mu equal to 250. Standard deviation sigma is 65. And now we want to know the probability that x is between 195 and 285 using the norm s dist function. We can also use the classical function, that's not a problem, but we're going to use the norm s dist function. So first we have to calculate the z value for the surface from x, 195, x smaller or equal than 195. So we find 195 minus 250 divided by 65 is minus 55 divided by 65. And that first surface using norm s dist is a z value of approximately minus 0.8462, or you can use the value in the field of Excel, and that's equal to 19.873%. So that's the probability that x is smaller or equal than 195. Now the next element that we do, we have to look at x smaller or equal than 285. So we find now the second z value is 285 minus 250 divided by 65. which is 35 divided by 65. And we find again the surface. We calculate this surface. We put the z value 0.5385 in the norm as this function. We add the parameter through, and we find that this surface is 70.487%. In order to find the probability that x is between 195 and 285, we have to subtract the first percentage from the second percentage. So surface 2 minus surface 1 is in fact 50.614%. So there is a 50% probability approximately that x is between 195 and 285. Now we can have another exercise. We look at the different graphs that we can draw, and we have the same average but different standard deviations. And we can now use the formula to create that function, to create that graph using these different standard deviations. Now here we have to use the norm distribution, because if we would use the same z value, we would find exactly the same graphs, because everything is around 0 and 1 standard deviation. So basically what we do is we calculate, or we select different values. I selected a certain number. You can select the range that you like, and you calculate the probabilities. Now in this case, with the parameter cumulative set to false, for those different values with those different standard deviations. You can do that in Excel. You make the table, and then you select the table and you create a graph. So you can do that. You can stop the video here, and let's have a look at the result after you're finished. So stop the video, do the exercise, and then you come back. So you finish the exercise, okay, or not. Let's have a look how the result should like. And of course, you can do it afterwards also. So here we see the different distributions, the different density distribution. And we see the first one with an average of 350 and a standard deviation of 15, which is the orange curve. It's like quite concentrated around the 350 value. I went here from 35 up to 655. You can select any range that you want. Now, when you look at the second distribution, 350 and 45, we are still around the same average, but we see that the spread is a lot more than the previous. There are more values to the left and to the right. And when we increase the standard deviation, we see that the curve is flatter and flatter and flatter. So it shows us clearly that with the same average, but with different standard deviations, you see that those curves are completely different. And it's clear to say that we would like to have a small standard deviation when we are producing, for example, parts, or when we are measuring certain elements. We like to have a small standard deviation, because then the values are closer to the, let's say, the average or the value that we want to realize. Imagine you want to produce a part with a certain weight of 350 grams. Well, the smaller the standard deviation, the more parts are close to that 350. And also you can imagine that when you have certain tolerances, that your parts cannot be, let's say, less than 295 or more than 415. Those are the parameters. You see that when the standard deviations increases, that you will have more elements that will be out of line, that are in fact not compliant. So basically here you saw some exercises. We will look at some other specific exercise, what we can use for our different distributions. Anyway, this is what I wanted to tell you in this video. Don't forget to click the subscribe button, click on the bell button, and I will see you in our next video. Thank you very much, and bye-bye.